Hello everybody. Today we are going to study about why asymmetric fission is more probable. So in the last lecture we have studied about what is nuclear fission, why uranium-235 it shows fission but not uranium-238 and all that. So here we are going to study asymmetric fission. Asymmetric fission is the one where the two fission fragments which are formed, they are not having equal masses. Symmetric fission is the one where the two masses which are formed, fission fragments which are formed, they have equal masses. Now fission is unsymmetrical and liquid drop model requires refinement because we explain nuclear fission on the basis of liquid drop model. So this is a parent nucleus which is considered as a liquid drop. This is the state before fission. So this, like a drop of a liquid, it also forms a dumbbell like a shape, and it neutron rich fission fragments in highly excited state. So they emit neutrons and these two fission fragments are formed which move in opposite direction, and motion of fission fragments and release of prompt neutrons. So this is how we describe fission reaction. Now the fission results in two massive fission fragments having equal and opposite momenta. Now this each fragment, it may emit 1 or 2 neutrons to be stable in less than 10 raised to minus 15 seconds. So the neutrons which are emitted within 10 raised to minus 15 seconds, these neutrons are called as prompt neutrons. So we have uranium-92-235 which captures one neutron and it forms a compound nucleus uranium-92-236 which is in the excited state. It undergoes fission reaction, forms fission fragments barium and krypton, and it emits approximately 3 neutrons. So this is reaction A. Now these fission fragments which are formed, barium and krypton, they must exhibit beta activity to get rid of excess neutrons. So this barium, it emits beta particles and antineutrinos, forms La nucleus. This La again, it is having excess of neutrons, so again it will show beta activity. It will emit beta particles and antineutrino and it forms Ce nucleus. Again it is having excess neutrons, so it will form Pr, will emit beta particles and antineutrino, and this Pr again being beta rich, it emits beta particles forming Nd nucleus, electrons and antineutrino, and this nucleus which is formed, it is stable. So now here the reaction will stop. So these are the chain of reactions which fission fragment is going through. Now similarly, as like in case of barium, this krypton which is formed in as this another fission fragment, that is also having excess of neutrons, and so as to get rid of this excess neutrons, this krypton nucleus will also show beta activity. So it emits beta particles and forms this nucleus. This nucleus again, it is having excess of neutrons, so again it will show beta activity. It will form this nucleus, again it will emit beta particles, again this nucleus will emit beta particles, and here the Zr which is formed over here, it is stable. So this chain of reaction will stop here. So here we have seen this equation A where uranium breaks into two daughter nuclei or fission fragments, you say barium and krypton. Now this is not the only one fission reaction, because whenever we talk about nuclear fission, generally we talk about this reaction where uranium, it forms barium and krypton. This is not necessarily the only type of nuclear fission reaction. Equation A gives one of the ways in which uranium-235 undergoes fission. There are more than 30 ways in which different pair of nuclei is formed. So instead of barium and krypton, you may have another pair that way. So there are 30 different ways. Here equations B and C which we have seen, here we got this chain of reactions, and now this chain of reactions which we are getting over here, this chain of reaction is also not fixed, and there are number of ways in which this fission fragments can form a stable nuclei. So there are about 60 such different types of chain reactions, and we have seen one of the type of such chain reaction. So the fission yield here we can define as Y of A. It is number of nuclei of mass number A found in fission upon total number of fission multiplied by 100%. So that is Na upon N0 into 100%. When percentage of fission yield is plotted against mass number A, we get distribution of fission fragments, and this is the kind of plot which we get. So here, if you check this point, the fission yield, it is minimum for symmetric fission, because when I'm saying 120, approximately like I'm having equal masses in the nuclear fission reaction. So for symmetric fission, you can see over here that the yield of the reaction, it is less. But for here and here, these two fission fragments, the yield is maximum. So what are the conclusions? Most probable values for the mass numbers of the two fission fragments are 95, this corresponds to 95, and 139. That means whenever we are talking about a fission reaction, the more probable values are with atomic mass number 95 and atomic mass number 139. Yield is minimum for A approximately equals to 117. That is symmetrical fission. Symmetrical fission yani uranium 235 it will break into two equal masses. Equal masses in the sense approximately 117 or 118. 235 hai, so that means 117 or 18 you say. So that is a symmetrical fission, and that probability is less. And for A approximately 95 and A approximately 139, we have yield is maximum, and for A approximately 117, we have Z approximately 50, and for that we are having the fission yield minimum. Why it is so? Because when we talk about Z equals to 50, in one of the lecture of shell model, we have discussed about magic number. 50 is a magic number. When number of protons, it is equals to magic number. In that case, it has a strong or high value of nuclear binding energy. And if as it is having high value of nuclear binding energy, it will be very difficult to break that nucleus. Fission basically it is breaking of the nucleus. So as for Z, corresponding to Z approximately equals to 50, nuclear binding energy is strong. Hence the fission yield will be minimum. That is also one of the reason that why for symmetrical fission yield is minimum. So the reason is for A approximately 117, that is for symmetrical fission, the value of Z, it is approximately 50. 50 is a magic number, and we know that for a magic number, binding energy is strong, and hence the fission yield must be minimum. Therefore, for uranium, asymmetrical fission is more probable as compared to symmetrical fission. Thank you so much.